Hi, when it comes to that of EDC and in transistor analysis, exam point of view, a very important question, a repeated question we have. It's converting the H parameters, expressing CE in terms of CB or CB in terms of CE or vice versa like that, or CE expressing in terms of CC. So majority times this is asked, like CB to CE, like we have this conversion, that conversion is repeatedly asked, exam point of view, right? So a detailed explanation, it will be lengthier, but trust me, it will be clear, right? Where to start the discussion from the very two-port network, with a one pair of input terminals and another pair of output terminals. We have V1 input voltage, I1 input current, and V2 here, it appears over here, V2 output voltage and I2 output current. The discussion starts from there. Hybrid parameters, two port network, and what is that standard expression? We have mathematical expression representing that one. When we consider V1 as a function of I1 comma V2, all right, and I2 as a function of I1 comma V2, right? So we have, if we consider V1 as dependent and V2 as dependent, that gives some sort of parameters. So in this case, that is a mixed parameter, so hybrid parameters, right? So what are the standard equations? Two important equations to be remembered for a beginner while this analysis is concerned. So what is that? V1 equal to, considering this one as a function of I1 and V2, so V1 equal to H11 I1 plus H12 V2. All right, this is equation 1, and we have another equation like expressing I2 in terms of I1 and V2. What is that? We have let that be I2 equal to H21 I1 plus H22 V2. This is equation 2. These are the standard representation, that's it. We express this very equation 1 and equation 2 in terms of CB, CE and CC when it comes to that of analysis part. All right. So and to go ahead with the conversion, with the derivation or whatever we are in search of, one need to have an idea on this one. So if we speak about common base configuration, how the transistor is arranged, right? One need to have an idea on that one. So common base, in the sense we have three terminals upon which one is base, and now this base will be common to both input and output. And when it comes to that of common base configuration, input is given to the emitter. All right, input is given to the emitter. So here emitter input, and what current will be over here? So in emitter, so this will be IE. All right, and output is collected across the collector, is in common base. All right, and its collector, so we have IC. Now this base is common to both input and output. Now this is a two-port network over here. Okay, so what voltage, you need to have a question. Now what voltage arises between over here? It's a VEB. All right, and over here it's a base, it's a collector, so we have V. It's grounded, it will be grounded, the common point. All right, so it will be VCB over here, right, which is very much similar to now this one. Now it's common base. Okay, now this one will be I1 and this one will be V1. This voltage is very much similar to the standard two-port network, and now this one will be I2. All right, this is I2 and this is V2. Now this is for common base configuration. All these terminals, this suffix and everything, this IE is for common base configuration. Now this has to be plugged over here. These two, writing these two standard, two important equations in terms of common base with these terminology. Now this is I1, this is V1, this is I2 and this is V2. So that has to be written, this standard equation in terms of CB. Let's see what is that, right? So V1, what's V1? That's VEB. VEB will be equal to H11. So please have a little groundwork before you come over here. If how this is HI, how this is HR, how this is HF, and how this is HO, right? I cannot explain all that now in detail. Why? Because this derivation itself is a bigger one. So try to understand that one. I have done a video previously in H parameters analysis. I'll provide you the link. Okay, so go through that, so then you can have how that is, how this one H11 is H, how this HI comes over here. All right, and yeah, we are talking about common base, so the suffix will be HI B over here. All right, so I1, what is I1? This is I1, so IE comes over here, plus this will be HR, reverse voltage gain, right? HR, and we are talking about common base configuration, and so the suffix B, and V2, it's a V2, so VCB, right? So the suggestion is focus on the suffix and suffix over here. I got confused. This is the third time I'm making the video because if there was a confusion over here. All right, so you have to have a careful watch while you represent this equation in terms of various the three configurations. Now this is in common base. All right, so first equation in terms of common base. Now how to obtain this hybrid parameters, parameter 1, parameter 2, 3, 4. There's a condition. So talking about this one, V1 equal to H11 I1 plus H12 V2. All right, so once we go for I1 equal to 0 and second time we go for V2 equal to 0, in the sense output open, which makes I1 0, and input open making I1 0 and output open making V2 equal to 0. So if this is the case, what do we have? If this is the case, we have I1 equal to 0, so we are left with V1, which is equal to H12 V2. All right, now this condition with H12 will be V1 by V2 for what? When I1 equal to 0. Now this condition is also very much important. All right, yeah, remember this one. All right, so in that case whatever second equation, when we write the second equation in terms of common base, this general one, this is in terms of CB, even this has to be written in terms of CB. What is that equation? I2 second output current, it's IC. All right, IC, which is equal to HFE. This will be HF. All right, forward gain HF, and it's a B because it's common base with respect to common base. And what will be I1? IE will be I1 for common base plus this will be HOB because of base configuration, and V2 is once again it's a VCB. It's a VCB. All right, so these two, this is equation 2 in terms of common base. All right, and so now this has to be put it in a circuit hybrid representation like this one. It's a voltage. Please watch again. It's a voltage which is equal to this voltage drop plus this voltage drop, right? So how this voltage is created? It's a current, and what multiplied with current will be a voltage. It's a resistance, and straight away we have a voltage over here. It's a V voltage multiplied with something, some constant. It's a gain, right? So it's a voltage. This is current multiplied with a resistance. So it's in the input side. All right, V1, it's a V1 which will be in the input of the two-port network. So where do we have in especially common base, when we draw for the common base, right? So input is given to the emitter in the common base configuration, and what current do we have here? It's a IE, right? It's a IE, and yeah, IE is flowing. So what do we have? What should we have over here to produce this drop? We need to have a resistance and giving the name HIB, and this product will give this drop. All right, and plus, and over here this should be, it's a voltage. How to represent that? It's a voltage. All right, voltage, and some times of, so HRB VCB. Now this will be a constant. Let's check what it is. And guys, if current is flowing in this direction, we'll have, this is very much important in this analysis, the polarity, right? You have to be careful with the polarity. So this will be positive, and here current is flowing in this direction, so it will be positive, and this is negative. Even over here it's a positive, and this side it will be negative. Very much important. Why? Because we have to obtain something. Yeah, let me tell you when time comes. It's important. All right. So which is equal to now. What is that? Now here it's a base, common base, isn't it? It's a base. Now V, E, B appears over here. All right. So this is what. In the sense base is somewhere else here. Base is somewhere else here. Base, which is common to both input and output. All right. So output is collected across, for a common base configuration, output is collected across a collector C, and what do we have? We have a current IC, right? IC is equal to this current. It's already a current multiplied with some constant. All right. And even this one we have, it's guys, it's a current. All right, it's a current. So how to say that? When we make I1 0, this is I1. When we make I1 0 to evaluate the hybrid parameters, what do we have? IC by VCB, which is equal to HOB. All right, it's a conductance. Now going back over here, when substituting HOB with IC upon VCB, this voltage and this voltage gets cancelled. We will be left with current only. That's current. It's a conductance. Conductance, not resistance, conductance. So conductance I by V, and that V, this V gets cancelled, and we will be left with I repeat, right? So it's a conductance. And guys, to my knowledge, capacitance, we go for a capacitor. Resistance, we go for a resistor. So what to be placed in case of a conductance? Insane question? No. We can do something like no conductance. We can replace a resistor whose value is the reciprocal of the conductance which we are talking about. Yeah, it's true. And so you have this one. So go for this one. IC, this current plus this current. It's a current. Yeah, it's a current. It's a current, but dependent. And so we have this one, which is equal to HFB IE. All right. So where do I write down this one to be more clear? I'm writing this one. All right. So it's a HFB IE over here, and we have it's a base. So it's base. Now base is common to both input and output. We have VCB, we have VCB, and if we have a resistor over here, that will give this current. But take a pause and concentrate on this one. HOB, while we go for the analysis, it's HOB, it's a conductance, and the conductance we place a resistance whose value is reciprocal to the value of HOB. So standard textbook says we go for this one. Check, come back with a comment. A resistance is placed whose value is 1 upon HOB, right? So you find this one. Analysis, we need a current, so we will go ahead with this one. But while representing in a circuit, we will go for a resistance whose value is reciprocal to the conductance, right? Now this will be the current over there, right? So this is the final hybrid model in terms of common base, general two-port network hybrid representation in common base. See this, it's in Thevenins and this is in Nortons. It's a combination, right? Thevenins, it's not a mixture. Norton, it's not a mixture. Here we have Thevenins, here we have Nortons. It's a mixture. We have a single circuit with a mixture of representation, and so it's a hybrid model, and that too in common base. Base is common to both input and output. All right, this is important in this conversion. On the other hand, if these two equations has to be expressed in common emitter configuration, CE, right? And one need to have an idea. In the common emitter configuration, emitter will be common to both input and output. Input is given to the base and output is collected across the collector for common emitter, isn't it? So in that case, what will be this current? It will be IB, and here we have IC, that two-port network representation in terms of common emitter. So it will be V, B, E, B and E. All right, now this will be the two-port network, like emitter being common to both input and output, and we have V, C, E. Now this one will be I1, V1, I2 and V2. Now this one, like common emitter in the standard form, how to write down those two equations? We have V, B, E equal to HIE, IB, I1 in terms of IB in place of I1 plus HRE all right. And the second equation, this will be the first one in the input side, V in terms of voltage, and IC will be HFE IB plus HOE VCE. This will be equation 1 and this will be equation 2. And in order to evaluate these hybrid parameters, we go for in order to evaluate this one, these four, we go for open circuit at the output and short circuit at the, open at the input side and closed short circuit at the output side. So what does that mean? We have making IB equal to 0 gives one set of hybrid parameters, and on the other case, when VCE is made 0, we have another set of hybrid parameters. So when IB equal to 0, in the sense when this is equal to 0, what do we have? VBE plus, which is equal to, this is made 0, right? Input is open. We have HRE VCE, all right. So which gives us HRE, which is equal to VBE upon VCE at what? IB equal to 0. Making IB equal to 0, we evaluate this one. This condition is very much important while we go in search of this conversion, right? And yeah, we need that one. And the other one, when VC is made 0, we can evaluate this one, all right? So that is the case. Now during this process, during this conversion, what we have to do is, guys, what we have to do is, this is in terms of common base, isn't it? Now this has to be redrawn for common emitter. This very circuit, I repeat, this hybrid model is in common base representation. Now this has to be, this one should be modified for common emitter, right? So once again, checking that for common emitter configuration, emitter is grounded, all right, emitter is grounded, input is given to the base will be the input and collector is the output, right? So according to this, in the sense, now this has to be made upside down, do some modification and has to be converted for common emitter configuration, all right. So this one, in that case, guys, a small modification to be more clear, all right. So for the time being, we don't need this one in this conversion, all right. Even this one, base is this, and even this one, all right. So this one, we have this one, right? And let this be converted for common emitter configuration, right? So guys, here this one, this saying this is this, all right. I repeat, what am I doing during this process, while we go in search of this conversion? This common base, this circuit which is in common base should be modified to common emitter configuration, in the sense input should be over here, output should be over here, this has to be grounded. So starting from here, this one, this junction, let this be that junction, right? Input, nothing from this junction to base, nothing is there. From this junction to the base, we have nothing, all right. Yeah, and output should be from here, so just a twist over here, all right. So continuing from here, it's like this, let me use a black one so that it will be more clear for you, right? And this one, this, all right, this with this one, see, and it's towards the junction, all right, it's towards the junction like this one, HFBIE. Don't get confused with the suffix, that does matters. Why? Because we are trying to express something in terms of something, all right. And this junction is over this junction, which is collector, and we have IC, all right. And what should be here? This one, this should appear, isn't it? This one, which is equal to 1 upon HOB, all right. We place a, HOB is conductance, so we place a resistance which is a reciprocal of that conductance, right? That one, right? And at the junction, at the junction emitter should be grounded, isn't it? So after this one here, after the junction here, we're coming like this one. What do we come across? We come across that one, which is here junction which is negative. All right, just pull it down this side upside down. All right, so we are grounding this one, so minus, go with this one. All right, and this side it will be positive. And what is this? It's a HRB VCB. all right, we are done with this one. Base is drawn, this is drawn, so started from the junction, we came across negative and then positive, again this negative. All right, this with the negative, with the positive on this side. See, we have come like this one, and so this is the emitter, which is, guys, done. What is it? It's a HIB. All right, it's a HIB. And now this will be the emitter. Which is common to both input and output. Right? This is the conversion, don't get confused. And here it's emitter, so we have IE. All right, so what voltage appears? It's an emitter. Here. Emitter is common to both input and output. So what voltage appears over here? We have BE. All right, and what voltage is over here? We have VCE. All right, we have over here this one, and we have this one. All right, guys, from the time your teacher will be saying something about a transistor, you might have been told, what is that? It's for a transistor we have IB, base current, plus IE plus IC, all the currents, sum of all the currents are equal to 0. Right? And what are we evaluating for? With making equal to IB equal to 0. The same thing is applicable over here. With IB equal to 0, making this 0, we have IC equal to negative of IE. Make a note of this one. Right? So what is that? The condition which we are trying for, the parameter which we are in search of, can be evaluated making use of the condition IB equal to 0. So when IB equal to 0, IC that side. Right? A very important representation which has to be plugged over here. All right, so this is, we are now this one, this ratio, whatever, should be evaluated making use of this circuit which gives this conversion. Right? Let's see what happens. And here what next? Now if this is the case, guys, we can have something else. From the circuit, this voltage drop is equal to this drop plus this drop. Where the hell did we get this drop? We place a resistance, right? We place a resistance from this point to this point. Let me erase this away. It's a current generator, all right? We have a resistance, so definitely we'll have a drop from this one. It's a V. It's a voltage between base. Nothing is over here. See, nothing is over here. So it's a base. So B to C. We have a drop. Yeah, we have a drop. We have a resistance. So definitely current is flowing through that one, right? And so we have that drop. So let me redraw this again. All right. So this is H F B I E. All right. So that one. And guys, there is another point to be noted over here. It's explained, it's given in few textbooks or not given in few textbooks. The thing is, you find, guys, we have IE, see, IE this side, and even IB. So where do this, does this IB and IE get 0 over here? No, that will be flowing to this side to become the load resistance, right? IC is flowing over this side. It may be going through this side and it may get split into this part, but point is IB and IE will be flowing against this, all right, against this, which will be the load current. So we have a current which will be, this is a very confusing point, you have to make a note of this one, IB or something else, some current will be flowing in this direction, all right? So we have a positive and a negative over there. So make a note of that one. So what will be IC here? What will be IC? IC will be equal to HFB IE, which is in the direction of IC, minus I. Let some current I given over here, I. All right, minus I over here. Let some current which is flowing in this direction be I. All right. So how to write down this I? How to write down the current, guys? Once again, I tell you, it's a resistance, but we have to go, when it comes to that of current, that will be, guys, that will be HOB VBC. All right. So then only it will be a current. If you go for this one, that will be a voltage. It will be voltage, but if you are writing for current, so this is the one. HOB, it's a conductance. I by V, this V and this V gets cancelled and we are left with I. Why? Because we are writing for I, isn't it? So that's the case. Very confusing, but repeat this, rewind this and get it if you are confused. All right. So IC, is this the same IC? Of course, the same IC. So minus IE, which is equal to HFB IE, negative of HOB VBC. All right. So what do we have here? This side, this, doing this, and this. What do we have? Interchanging, which is equal to HFB IE. It's negative. Going that side will be positive IE, and it's negative. This side will be positive HOB VBC. All right. So which is equal to what? Taking IE as common, from here and here, we'll be having IE, taking out IE as common, we'll be having HFB plus 1, and so IE will be equal to HOB VBC upon 1 plus HFB. All right. We need this one. We need to plug in somewhere in the discussion. All right. So that will be very important. A game changer, we can say, that has to be plugged in somewhere to obtain. Why? Because we need this VBC. All right. So guys, in that case, this VB over here and these two drops are in parallel with this one. So how can that be written? This voltage drop is equal to this drop plus this drop. VBE is equal to this drop plus this drop according to the Thevenins, etc., etc. VBE will be equal to VBC plus this drop plus this drop, VCE. All right. So this point, okay, this point, and from this point to this point, it's in parallel with this one. So this drop will be equal to this drop, whatever drop. Even this is true. Even this drop is equal to this drop and equal to this drop also, right? So the same VBE, right? The same VBE. Do we need this? We need IE. All right. We need IE. And this same, we are going for HRE, isn't it? HRE, which is equal to VBE by, more clearly, VBE by VCE, and VBE we have this one, which is VCE plus VBC upon VCE, which is equal to 1 plus VBC by VCE. Guys, we have to search for this ratio from here. Plug in over here, that will give us HRE. All right. So here, and what? This condition is for when IB equal to 0. That's the condition, right? To evaluate the H parameters. All right. So now with this one, we have a output loop. It's a closed, from this point to this point, it's a closed loop. So considering the output loop, output voltage drop over here. All right. Not about this one. Considering how to write down that one. This drop, come, go in this direction. All right, going in this direction, all right. Start from here, start from this point, positive. So what is that? Positive, it's a positive. We start from here. Okay, we came across positive. H I B I E. Again, what is this drop? It's a positive plus H R B V C B. Yeah, go ahead. Even this is a positive, and this is the voltage drop. This can be written, even this can be plus V B C. This is the drop, direct voltage drop. Write down the drop. And even this one, even this will be positive, it will be negative, plus V C E, which is equal to 0. All right. So guys, now this is from the output circuit. All right, output loop, and we have IE over here. This has to be kept in mind. Rewriting this one, how can this be written? It's a HIB from here, and IE we have that one. What is that? HOB multiplied with VBC upon 1 plus HFB. All right, plus HRB. Sorry for the inconvenience with my script. It's a HRB VCB plus VBC, which will be equal to negative VCE. It's this positive this side, going that side it will be negative, right? I have written that one. Why? Because we are in search of this ratio. See, we have VCE over here. This ratio VCE, we have VCE, VBC is here, VBC is over here. What the hell is this doing? VCB. Now what to do with this one? We want VBC, isn't it? So in this case, what we have to do is, it will be a negative. It's a negative VBC. All right, now we have VBC over here, VC. Then we can go for that one. We can evaluate that one. Just rearranging this one. What do we have? HIB, HOB upon 1 plus HFB minus HRB plus 1, right? Which is equal to minus VCE by this one, VBC is common from all the terms, and doing that side it will be VBC. All right, so this can be here 1, like plus 1 minus this one. All right, so by 1, so simplifying this one, what do we have? 1 plus HFB. All right, cross multiplying, that has to be done, isn't it? HIB HOB plus 1 plus HFB into this 1 minus HRB, which is equal to negative of VCE by VBC. All right, so this one, what do we need? We need this ratio, and the reciprocal of this one will give us that ratio. What is that? VBC by VCE will be equal to, we have this negative that cannot be neglected, that negative appears over here. Reciprocal, negative VCE by VBC, we want this ratio, so the reciprocal minus of 1 plus HFB upon HIB HOB plus 1 plus HFB into 1 minus HRB. All right, guys, so this is the expression for VBC upon VCE. 1 plus this will give us HRE, and that too in terms of emitter, in terms of base. All right, so that's what which we are in search of. So how that is done? HRE will be equal to 1 plus VBC by VCE, which is equal to 1. This ratio is negative, minus 1 plus HFE upon HFB. I am sorry, HFB upon HIB. All right, HOB plus 1 plus HFB into 1 minus HRB. All right, so that will give us HRE, the values of HRE, and this can be still simplified, further simplified to what, which is equal to the LCM. It will be LCM HIB HOB plus 1 plus HFB into 1 minus HRB. Right, so cross multiplying this one, this 1 into this one, it will be HIB HOB plus 1 plus HFB into 1 minus HRB, right, into this minus 1 plus HFB. All right, there is a small confusion. Usually the student gets confused in the simplification over here. The denominator as it is, HIB HOB plus 1 plus HFB into 1 minus HRB as it is. So guys, if we have HIB HOB, no change in that one, plus we have 1 plus HFB from here. All right, even 1 plus HFB from here, taking out 1 plus HFB as common from here, and here what it is, 1 plus HFB. All right, into this has come out, this has come out, this has come out, we are left with this and minus 1 over there. So it's a 1 minus HRB minus 1 from here. All right, this has come, so this has come as it is, and minus 1 from here, minus 1. All right, so a small simplification over here itself. I cannot do it. Let us do it over here. So this positive 1 and negative 1. All right, right, and here a very important point to be noted is HRB is very much lesser than 1. It will be 2 into 10 raised to minus 4. So 1 minus this one. So HRB can be neglected when compared to 1. So we don't have this neglected. So we will be left with this one only. All right. In the sense 1 into this thing, it's this thing. 1 plus HFB is very much higher than this product. It will be, this will be proved, isn't it? So this can also be neglected. All right. Right. So in that case, the final, let me write over here, the final reduction is, if this is the case, here it's a HIB HOB, all right, HIB HOB upon 1 plus HFB, and we have this negative minus 1 plus HFB into HRB by 1 plus HFB. All right, so this 1 plus HFB in the denominator and numerator gets cancelled. We have this one HRB, and this is the approximate value of HRE in terms of HRBC. It's a E and all the terms are in B conversion, obtaining C, expressing emitter parameter in terms of base parameters, right? So hope you understood the analysis. Thanks for watching.